Okay, so hello everyone. Today, I will be discussing two examples for the problem solving in getting the electric force of two or more point charges. So, for example one, we have here 2 point charges, the Q1, which is equal to positive 25 nanocoulomb, and Q2 equal to negative 75 nanocoulomb, are separated by a distance r equal to 3.0 centimeter. Now find the magnitude and direction of the electric force. The first one, Q1, that exerts on Q2, and B, Q2, that exerts on Q1. So here you can see images of the two charges. For figure A, we have here the positive Q1, or the positive charge, and then the negative charge, which is the Q2. So if we have two opposite charges, it basically attracts each other. So for the free body diagram of charge Q2, this is the force Q1 exerts on Q2. So kung ano yung force na ini-exert ni Q1 kay Q2, so basically it attracts Q2. So the direction of Q2 is going to Q1. Okay, so your force 1 on 2 is going to the negative x direction. So here we are going to use your Cartesian plane as a reference of the direction. So here we have negative x direction, or to going to the negative direction. And then for the force Q2 that exerts on Q1, so this is force 2 on 1. So kung ano yung um, attraction ni Q2 kay Q1. So what happens is attracted si Q1 kay Q2, basically dapat lalapit siya kay Q2. So ang direction naman ni Q1 is going to the positive side, or going to the right side of our Cartesian plane, or our x-axis. So here, your sign, expected direction of your force is positive. Dito naman, your force is negative. You have here a negative force. This one is a positive force. Okay? So in solving this, we are going to use your Coulomb's law, or the formula for Coulomb's law, which is F is equal to 1 over 4 pi E naught Q1 Q2 over R12. So this is the absolute value. If you're going to get the magnitude, you have to denote this as an absolute value. Now this variable here is equivalent to what we call the K constant. Okay, your K constant is given as 8.99 times 10 raised to 9 Newton meter squared over C squared. So this is a constant value. So other books uses 9.0. So kung i-round off ninyo ito, it's 9.0. So other book or other references use 9.0 times 10 raised to 9. So in this example, we are going to use the 8.99 times 10 raised to 9 Newton meter squared over C squared. So here, we will write the given. So the given in the problem is the charge for Q1 is positive 25 nanocoulomb. If you see this small letter n here, this is equivalent to times 10 raised to negative 9. Okay, so this is just 25, positive 25 times 10 raised to negative 9 coulomb. Okay, so kailangan natin siyang i-convert into coulombs. It's because our constant is in coulombs. So para ma-cancel ito siya, dapat coulombs lang ito siya. Okay, so we have to transpose or to convert your nanocoulomb to coulomb. So this is now your Q1. Okay, and then our Q2 that is negative 75 nanocoulomb. Okay, so this is just negative 75 times 10 raised to negative 9 coulomb. Okay, now our distance or our R, 1, 2, that is 3 centimeter. So since naka-centimeter yan siya, and then our constant is in meter, we will convert first your centimeter to meter. So your 3.0 centimeter is equivalent to 0.03 meters. Okay? So you convert your centimeter to meters. Now you have now um, given values which you can uh, substitute to our formula. Okay, so we are going to substitute this to our formula. Okay, this is your K. So I will write your K as um. So your force now is equal to 8.99 times 10 raised to 9. Okay, this is Newton meter squared over c squared, okay, times the absolute value of your positive 25 times 10 raised to negative 9 coulombs times your Q2, which is the negative 75 times 10 raised to negative 9 coulombs, okay, over 0.3 meter squared. I'm sorry, 0.03 meter squared. Okay, so you plug in this in your calculator. So you can write it this way, 8.99 times 10 raised to 9. Sorry, 9. Okay, and then times fraction form. You have here the absolute value. So you can just neglect your positive and the negative sign. Okay, so that is 25 times 10. Sorry, parenthesis 25 times 10 raised to negative 9, and then times the 75 times 10 raised to negative 9. Okay, and then your denominator, which is the 0.03 squared. Okay, so you will get 0.0187, or you can round it off to 0.019. Okay, so what will be your unit? So the unit for force is newtons. It's basic, makancel si meter squared dito, and then si c squared from here, tapos yung denominator ng constant natin. So the answer now is your 0.019 newtons. So this is the magnitude of the electric force. So we have here only two forces, si Q1 and Q2. Basically, yung magnitude ni Q1 that exerts on Q2 and Q2 that exerts on Q1 is equivalent. So the same lang siya. So I will write this, F1 on 2 is equal to F2 on 1, which is the 0.019 newtons. Now this is only your magnitude. Now you're asked in the problem the direction. Okay? So kanina, I have here the direction in our free body diagram. So this is very important in determining the direction of our forces. So we will apply your F1 on 2 is in negative. So you can write this F with an arrow at the top since we are going to include direction and your force now becomes a vector. So F1 on 2 is equal now to negative 0.019 newtons. Okay, and then your F2 on 1 will be positive 0.019 newtons. Now this is your final answer. This is for A, and then this is for B. This is now your final answer for this problem. Okay, for the example number 1. Okay, so that is the negative 0.019 newtons for force 1 on 2. And then for force 2 on 1, that is positive 0.019 newtons. Now, for the second example, we have now three charges. Now, what if we have more than two charges? So we have here three charges, Q2, Q1, and Q3. So the question now here is to determine the magnitude and direction of the net electrostatic force on Q1. So electric force or electrostatic force or electrical force are all synonymous. So the same lang yan sila. We are still going to solve for the force, and then we are going to use our Coulomb's law. Now, in this case, this is quite tricky compared to the first example. It's because we are going to have three charges, and then we are going to determine the charges, or I mean the force exerted by Q2 on Q1, and then the force exerted by Q3 on Q1. So I have here another free body diagram. So here you can observe the force exerted by Q2 on Q1 is going to the negative direction. Now, why or how can we determine the direction? So look at the charges. We have here a negative charge, positive charge, and then the negative charge. If I will going to um, redraw or illustrate the given, I have here negative charge, I have here the positive charge, and then the negative charge. So this is your Q2, Q1, and Q3. Now we are going to determine the direction of force Q2 exerts on Q1. So anong nangyayari kay Q1 when we have a negative Q? I mean, a negative charge. So since positive at saka negative itong isa, your positive charge will be attracted to Q2. So yung direction ni Q1 now is going there. Is going kay Q2. Okay? And then, what happens to Q1 if we have another negative charge to the other side? Okay? Dito sa kabilang side ni Q1. Basically, attracted din si Q1 kay Q3. It's because they have opposite charge. Okay? Or opposite signs. Okay? So, um, the force exerted by Q3 on Q1 will be going to this direction. Going siya sa positive. While the force exerted by Q2 on Q1 is going to the negative direction. Now, how are we going to denote this? We are going to have force 2 on 1 and then force 3 on 1. Okay, ito yung hahanapin natin or isa-solve natin. Given, okay, we are going to write the given. So you have your negative, your Q2 is negative 4.0 microcoulomb. So this sign, if you can see this is mu. It looks like letter M and letter U, small letter M and letter U. This is actually a Greek letter. So we are going to call this mu, which is equivalent to 10 raised to negative 6. Okay, so this is a microcoulomb. Okay, yung kanina nanocoulomb yun siya. This one is microcoulomb. Okay, so you can write this or you can convert this as negative 4 times 10 raised to negative 6 Coulomb. Okay. The same with the Q1, that's positive 3 microcoulomb. So we can write it as positive 3 times 10 raised to negative 6 Coulomb. Okay. And then our Q3, which is the negative 7 microcoulomb, that's negative 7 times 10 6 columns. Now, what about the distance? Okay, so I will write here the distance of Q2 from Q1. So R21, that is 0.2 meters. So no need to convert it kasi naka-meter na yung unit niya. And then we also have your distance from Q3 to Q1, which is 0.15 meters. So in solving this, you are just going to substitute this given doon sa ating Coulomb's law. Okay? So we will start solving first the force of 2 on 1. Okay? So force 2 on 1, the magnitude. Okay, so that's 1 over 4 pi E naught. This is Q2 Q1 over R21. Okay. So since yung charge, yung force muna between Q2 and Q1 yung isosolve natin. Okay, for this two. Okay, so I will substitute the constant, that's 8.99 times 10 raised to 9 Newton meter squared over c squared. Okay, multiply it. Again, we have the absolute value. It's because magnitude lang yung isosolve natin. First, that's 4 times 10 raised to 6. Then multiply it by 3 times 10 raised to negative 6. Okay, so that's negative 6 over 0.20 or 0.2 meters squared. So you plug in this, your calculator. So you will get 2.697 or 2.7. So you round it off. This is equivalent to 2.70 or 2.7 newtons. Okay, so this is now your force 2 on 1. Okay, now what about force 3 on 1? So you will do the same but with a different given since different yung magnitude ng Q3 natin and Q2. So I'm sorry, that's 3, 1. So I will substitute this with the given times 10 raised to 9 Newton meter squared over c squared. Then multiply it by the absolute value of negative 7 times 10 raised to negative 6 Coulomb times 3 times 10 raised to negative 6 Coulomb over 0.15 meter squared. Okay. So in plugging in the values of Q1 and Q3, I intentionally neglect the negative. Okay, from the negative 7 here, it's because we are dealing with the absolute value. So the signs are not that important in getting the magnitude of the force. Basically, yung sign natin for the charges are only important if we are determining the direction. Okay, so kung positive or negative ba siya, are they attracted to each other, or if they have both negative or both positive, they will basically repel each other. So here you will get 8.4 or 8.39 newtons. So your force 3 on 1 is 8.4 newtons. So now you have the magnitudes. Now, going back to the problem, what was asked is the magnitude and direction of the net electrostatic force. Now, when we're talking about net, you have to get the total force in the system, or in this yung total force or electrostatic force na na-experience ni Q1. Okay. So we are going to add our two forces, but here kailangan na nating i-consider yung sign. Okay, so this is now F with an arrow above. It's the net electrostatic force is equal to your force on 1 plus your force 3 on 1. Okay, so you can observe here, meron na tayong arrow sa taas. So we are going to consider now your sign. Now, kanina, we determined the sign of F2 on 1 and then F3 on 1. So your F2 on 1 is negative, and then your F3 on 1 is positive. This is negative, this is positive. Okay, ito yung direction ng forces natin. So, your F2 on 1 now is negative 2.7 Newton plus positive 8.4 Newton. Okay, so you're going to add the 2. So that's negative 2.7 plus the positive 8.4. So you will get 5.7 Newton. So this is positive 5.7 Newton. So this is now your final answer for this problem. Okay, or for example number 2. Okay, so those were the examples for the electrostatic force. I only gave two, the two charges and then the three charges system. So if you have questions and clarifications, please send me a message through my Facebook Messenger. Thank you for listening. Thank you for watching. And I hope you understand our examples.